Friends, today we are going to discuss the different type of boiler used in industry. In my previous section post, I have discussed about the properties of steam, and now we are going to discuss the different type of boiler used in industry. Before going to discuss the different types, just I want to tell you one very important thing. What is the definition of boiler? A boiler, as per the definition of the boiler, a boiler is steam generating closed vessel whose minimum capacity is 22.75 liter. That is called the boiler. And then another one important definition is there, the equivalent evaporation of a boiler. What is equivalent evaporation of a boiler? Now, equivalent evaporation of 1 kg of water at 100 degrees centigrade, 1 kg of water at 100 degrees centigrade into dry saturated steam at 100 degrees centigrade at standard atmospheric pressure of 1.00332 kg per centimeter square. That is called equivalent evaporation. What is that value of the equivalent evaporation? Now that is 4. That is nothing but the latent heat at 1 kg per centimeter square and 100 degree centigrade temperature water that will convert into 100 degree centigrade temperature of steam, dry saturated steam. For that 540 kilocalorie per kg of energy is required. So what is the condition? Now feed water supplied to be at 100 degree centigrade. Evaporation of steam take place at 100 degree centigrade, and the steam will get that is just dry and saturated. At that time, what is the capacity? What is the heat required? That is called latent heat. That is 540 kilocalorie per kg. Next is your when the boiler the regulation has taken place, because in 1863 in Calcutta there are several several steam boilers explode in Calcutta, causing lot of fatalities, and that fatalities this fatal industrial incident accident shocked the British Raj. At that time they are ruling the India. Then they try to develop. Then they developed that direct develop a law that is called Bengal Act 06 of 1864, eh, and then the marking and beginning of formal boiler safety and inspection legislation in India that take place. Similarly, in Europe and USA, lot of explosion take place. War explosion take place, particularly in 1911, and there also they have forced to develop a law that is called ASME boiler and pressure vessel code, that is B&P PVC, that was developed in 1911. So there are all the regulations are all over the world. We are following this regulation. Europe, we are following ISO. USA, we are following ASME section 8 division 1, 2, 3. In India, we are following boiler manufacturing of boiler as per Indian Boiler Act Regulation Act, that is 1923 Amendment 2007. So now construction wise, now classification of boiler as per the grade of firing, as per the firing methods, we have classified the boiler as grate firing, traveling grate stroke firing, front fire burner, tangential fire burner, opposed jet firing, then down jet firing and cyclone firing. These are the types of firing based on the firing methods. These are the types of boiler we are using in industry. What is grate firing? Grate firing means you see this is the grate, the high temperature plates are there, perforated plates are there, and slightly slopes, and there from the top of the fuel input, and this is the ram. As per load, you are pushing this ram so that the gap, as per your load, the fuel will go inside the grate. From the bottom, primary air will be injected, will be introduced, and then firing take place, and the flue gas will go from the water wall to the superheater, and the finally it will go to the atmosphere. and these grates with the help of a tie rod, the by poking rod, we are collecting the ash in a conveyor and then discharging outside. But it is the outside, and this is the traveling grates. Here are the chain grates. You see the grates, it is moving. That is slots. So there are a lot of slots mounted together with this chain, forming a chain, and it is rotating through a power, and these are perforated grates, and then from the bottom we are introducing the primary air, uh, and the plug and the fuel will pass through, fall on the grates with the help of a ram. As per your load, the fuel will come inside the above the grate, and it is moving towards the right hand side and fall after complete burning. It is the ash will fall continuously falling, and that will be collected through conveyor. It will be discharged outside. Discharged outside. Overfire also of secondary air, we are also we can add to complete the firing, and then this is also the moving grade. This is called the moving grade. This is the fixed grade. So at fixed grade, so get grade firing using the fixed stationary grade where fuel is sit still and requiring manual and intermittent clearing of ashes, and traveling grade uses a continuous loop flexible metal link or bar driven by a motor acting like a conveyor belt inside the furnace. Inside the furnace, it is moving. It is moving. So it will take the fuel from the left hand side to right hand side. So by this time, the air it will come in contact with with air and burn. And when it reach to the right hand side, it will be completely burned, and the ash will fall down continuously. Advantage. Then ash removal, here also ash removal for the fixed grade, it you have to take the help of a scrapping, and then you can clean out the grades, but in a traveling grade, and it is continuously moving, so it will be collected on the other side of the grade, and it will be easily collected. Then, as for the firing, this is called the front firing. This one is the front and rear opposed, front and rear wall opposed firing. This is the side wall opposed firing. This is the corner firing. This is the corner firing burners. Burners are at the corner. Now, the advantage of the front firing, you see the front firing, this is the front firing, only one side burners will be there. So, advantage is that all burners are at the front side, simple, easy, pipe work is also require only one side, and burner can be accessed from the bottom to one side. There is no need of very big scaffolding. Will observation of the burner is very easy and well suited for small retrofitted in industrial boiler. Disadvantage is there, but is NOx will be there, high NOx will be there, and the flame height length is more, then this can strike the other side of the wall, other side of the water wall, and can damage the water wall. Damage the water wall. So this is the only disadvantage, and NOx formation plus high risk of hot peak zone near walls. Acha. Then front and opposed firing, front and rear, there also burners are mounted on the front side as well as the rear side. So cost will be advantage is there. The better turbulence at the middle, mixing will be better, and so heat distribution will be uniform, and high capacity performance, fuel flexibility, different type of fuel can be used, gas, oil, and coal. And but as the burner, you have to mount it on the both the side, front and rear. That's why your pipe and duct size involvement will be there in the both side. Structure size also require both side. That's why it is complex design, and your A will also be costly. Ducting and structure will also be costly. Similarly, corner fire, corner fire here drawing you have seen. This one is the corner fire. This is the corner fire. Here you see the advantage is there. Burner are mounted at the corner and continuous in an intense mixing created a self-stabilizing flame. Because all the, from the corner side, so all flame will become to the center of the furnace, and now NOx generation will be very less, and this and reduce thermal stress on the wall, because it will not flame will not go directly impinge on the wall. And highly, but disadvantage is you have to generate the fireball. But for the to generate the fireball, it is required some skill, because and skill that is uh, difficult to scale down for small operation. It is control system needed. Tilting, you have to tilt the burner. That is very precise operation is required. Imbalance, if any imbalance is there between the burner flames, then the central fireball will not be generated, and then uniform heating will not be there. A side firing boiler, that also the like front and rear, yeah, transverse mixing will be there. Transverse mixing will be there. Yeah, but here also the costly, because all the four sides you require ducting. Here also all the left hand side, right hand side ducting is there. Here also turbulence will be there at the middle. And if any angle changes, then side walls will be overheated. That's why skill operator is required. Skill operator is required. Now you see the fireball for the tangential firing boiler, different angle, they tilted the burner in different angle and create that fireball. To create this fireball, it is very important, so that your uniform heating will be there, no impingement will be there. So we should not avoid the fireball. You have to create the fireball in tangentially fire furnace. The central rotating fireball is intentionally created by aiming corner burner at an imaginary circle at the middle, imaginary corner at the middle, and that will flame stability, stable combustion, uniform heating, everything will be there if you can able to generate the wall. Similarly, here the turbulence will be, we see the back to back, from this side and rear side, they are flame are striking each other. There are lot of turbulence will be there. There are also if your angle is changing, then it can hit the side wall, or side wall bound by, if the burners are mounted on the side wall, left hand side, then also this type of turbulence will be there, and your angle of tilting is more, then it can impinge the wall side, tubes of the wall side, and can damage the tubes. Otherwise, the uniform heating will be there. Then top firing, you see burners are mounted at the top. Then flame will be there at the go at the bottom, and then it strike back and go to the other top, again strike back and flow reverse side. But this type of boiler burners are nowadays are not used. Now almost we normally prefer the tangential wildfire arrangement, 12 arrangement. This type of burner at the top fire burner, normally we are trying to avoid, avoid, because the flame reverse direction, flame first go down and then come back. You have travel at the reverse direction, content. So with high this design provides a long flame path and can improve combustion of certain coals with high volatile matter. Well, high volatile matter, but it is not used normally. Then cyclonic fire, you see the barrel types here, fuel we add with air are passing through the center, and then secondary air passing through the annular spaces. It will go and create a cyclonic motion of the flame, and then tertiary air you are adding at the burner flame outside, inside the furnace. So and it is so hot, the slacks are coming down. So coming down here, NOx formation will be there. NOx formation will be there, and this is also it offer high intensity combustion, handle lower grade crust coal also can be used. This is also burner we are using in the boiler. One type of burner we are using in the boiler. Then classification based on the energy source. Your what is the source of energy? That means coal you can use, then coal burner, coal fire boiler, liquid if you are using, then liquid fire boiler, gas fire boiler, solid waste fire boiler, biomass fire boiler, recovery fuel RDF boiler, waste heat boiler, nuclear type of nuclear fuel you are using, the nuclear boilers. So this is depending upon the source of your fuel. The boiler can be classified like this. Suppose liquid fuel, what are the liquid fuel we are using? Liquid fuel like light diesel fuel, LDF, and furnace oil, FO. What is furnace oil? And it is come under liquid fuel. It is thick residual petroleum product, like thick residual petroleum product are last. The thick residual petroleum product are we get that also can be used as a liquid fuel in the boiler. Biofuel, the renewable type, just like we are cultivating the biodiesel, and then from there we are getting the oil, while the oil that also can be used as a boiler fuel. Then solid waste, like in the way municipality, lot of waste are there, like recycled plastic, paper, cardboard, textiles, agricultural waste like rice husk, sugar cane. After taking out the sugar liquid, the residue which cannot be used, that all can be used after dry, can be used as a fuel. That is called solid waste. And biomass, like rice husk, groundnut shell. Groundnut shell, after taking the groundnut from the shell outside, can be used as a fuel in the boilers. Then corn cobs, bagasse from the sugar cane, in the wood mills, there are a lot of dust will be there that can also be used as a biomass in boiler, called biomass fuel in boiler. Then, as per according to the use of steam, sometimes utility boiler for generating, if a boiler manufacture the steam will start, rotate the turbine will generate the power, that is called the utility boiler. Like industrial boiler, cogeneration boiler, naval also, naval area, we are marine area, we are using the boilers, that is called naval boiler. Domestic heating purpose we are also using some boiler. Cooking purpose also we are using some boiler. So these are the classification as per the use of steam. Cogeneration, what is cogeneration plant? Suppose we are using a steam turbine, gas turbine, and the waste gas turbine you are taking air from the outside, compressed it with compressor, then combustion, that air is used in the combustion chamber, then high temperature gases will be generated, flue gas will be generated, that will pass to the gas turbine will rotate and will generate power, and exhaust from the gas turbine you can discharge it to the atmosphere, or you can utilize that exhaust steam around 500 to 600 degrees centigrade to generate power steam in a, that is called HRSG, heat recovery steam generation, and that steam will be generated. That steam can be used in the turbine to generate power, or can be utilized the steam in process unit. That is called the cogeneration plant. That's why the cogeneration plant, the efficiency of the plant will be 80 to 90%. Otherwise, normal plant efficiency, when we are not using the utilize the exhaust from the turbine, that efficiency will be 35%, and that will be discharged to atmosphere. So their efficiency will be reduced. But cogeneration plant, when the exhaust from the turbine, gas turbine, utilized to produce steam, that steam can be used in a process plant or to generate the power. If you are utilizing that flue gas, then your efficiency will increase. Then according to the type of construction, it can be packaged boiler like fire tube boiler, it can be packaged boiler like water tube boiler, it can be field erected also, that is called energy as per the construction. Similarly, as per the water circulation, it can be natural circulation, it can be forced circulation, it can be combined circulation. It can be combined. That is the forced circulation. You see the combustion process. This is the flue gas, heat is flowing, and here we are using a pump, using a pump to for to boiler. Apart from boiler water pump, there will be another one pump which will circulate the water through the chamber, through this furnace. It will go to the start drum, and then from drum it will go to the steam. Generate the steam, and that steam we are using through superheater. After superheater, we are using in the process plant or power generation. That is called the forced circulation. It is a, and it is the combined, because here you see the from the this is the superheater, and this is the feed water. Water is coming by the feed water pump. Then downcomer. This is not come in the heating process. That's why your density is higher, and this is the heating process. Density of the water is less, and due to the density difference, the circulation will be natural. But if you want to make it a combined one, then you can use a pump, circulating pump, that will further enhance the circulation. That is called the combined circulation boiler. Combined circulation. This is the forced circulation, and then there is a natural circulation. This is called the natural circulation. You see, from the economic boiler feeder pump will go to drum. From drum, the downcomer will not come on the furnace, inside the furnace, and then furnace, and that will heat the water, and water and steam go to the drum. That will, them due to density difference, the circulation will take place automatically. That is called natural circulation. Here another one, natural circulation plus another one pump is used, that is called forced circulation. That is called for combined circulation or forced circulation. Combined circulation or forced circulation. That is also one type of boiler. We are using both combined, forced and natural. Then basic type: fire tube boiler, water tube boiler, heat recovery boiler. You see that this is a simple configuration of boiler. Here you are taking ambient air through fan, FD fan or ID fan. FD fan we are using. Then through preheater, we are heating the with exhaust flue gas. Temperature of the air will be increased. Then we are using this hot air for in the burner, as well as we are using the hot air in the coal. Through air, it will go inside the furnace. Inside the furnace, from radiator and boiler feed water pump, you see the feed water will go to the drum to downcomer to riser to drum again, and then from steam will go to the superheater, and it will go to outside. And if you, from the turbine, if you are taking any bleed and you want to reheat it, then you reheat in the flue gas path, and again you are using in the boiler. This is a simple configuration of boiler. Here air path, feed path, water path, and steam path has been shown, and coal, fuels also path has been shown. Now fire tube boiler. Fire tube boiler, normally gas is flue gas will pass inside the tubes, and outside the tube will be the water, and very big drum will be there. The water and steam will generate, but the fire tube boiler we cannot use very big capacity or high pressure, because if you want to generate high pressure, your drum size will be drum thickness should be more, because if you increase the drum diameter, your thickness should also increase as per your pressure, because you know hoop test is PD by 2T, so that will be costlier. That's why we are using fire tube boiler for a medium steam capacity, that is 12,000 kg per hour, and lower pressure 18 kg per centimeter square. Operate with oil, gas, and solid fuels, and not suitable for large power plant. We are not suitable for large power plant. Then advantage of fire tube boiler is a compact construction, economical, smaller one, and accommodate fluctuation of steam demand. Term demand fluctuation is there, but as the cell size is more, so steam accommodation will be more, so fluctuation can be accommodated. That is the advantage. Disadvantage is water quantity required for steam generation is very large. and so it takes long time to generate steam. You have to use in the water in the drum to generate the steam for a huge quantity of water. It will take long time to generate steam, and then water and steam in the same vessel, as it is water steam vessel, limits use to low pressure application only, because it high pressure high thickness material will be required, that is not possible. And steam outlet will from the boiler will always be cannot be very much dry, because water are also there. So this will be steam outlet from the drum will be not very dry. Water tube boiler, the tube from the drum, through these tubes water will come to the bottom drum or to the ring header, and through riser it will go back again the drum, and from drum steam will be taken out. So here outside will be flue gas. You see the gates where firing will take place. Flue gas will pass through these, passing through these tubes. It will heat the exchange the heat, and your high pressure generation is possible, because the tubes size is very small. So high thickness tube can be manufactured, and their high quality pressure which can be generated. So the capacity will also be high, 4,500 to 1,20,000 kg per hour, and kg per hour, and your pressure will be also 140 kg per centimeter square can be generated here. Large heating surface, the conventional flow and high pressure 140 kg per centimeter square also can be manufactured. Disadvantage is not compact design, with surface area furnace surface area is high, not economical, and transportation will be difficult, because you have to erect this all these things at site. Heat recovery area means apart, you have seen the gas turbine, exhaust from the gas turbine. If you are venting it to the atmosphere, then that heat will be lost, will be losing. So if you are utilizing this gas for generating the steam, then HRSG, heat recovery steam generation plant, can be installed, and their steam will be generated, and then steam can be used for either for generating the power or can be used in the process plant. Process plant. That's why it is called heat recovery. But there no direct furnace burner will be there. Some supplementary burners are there to maintain the temperature of the steam. Otherwise, like normal conventional boiler, there are a lot of burners are there. There most of all the fuels will burn. But here the flue gas from the gas turbine are utilized to generate the steam, to heat the water to produce steam. So, friend, I think I have discussed all these things, types of boiler, different types of boiler use, definition of boiler, and um, um, the advantage, disadvantage, different types of boiler, water tube boiler, fire tube boilers. If you go through the slides, your concept will be totally clear. And if you like these slides, you will be benefited. Certainly, then give a tick mark and subscribe this channel, so that the lot of other post for boiler are going to come. We will be benefited. Not only you will be benefited, if you subscribe it, and yeah, and make your friend also, you can help it. You help your friend by let them also know this channel, so that they will also be benefited. They will also be benefited. Uh, and if you have any queries, you can ask me, or through mail, through telephone, or video conference can be arranged. So, and this chapter certainly give you insights, increase your insight. Type of boilers used in the industry will be, you will be able to reply, and different classes, different types of boiler we are going to discuss in detail later. But now these are the, in short, the all the types of boiler used in the industry has been discussed in this channel.